Stand on the wet clay at the edge of the limestone cut, just where the backhoe bucket bit deep into the gray soil of Washington County, and what you see is entirely ordinary. A road crew widening a two-lane highway, a drainage ditch filling with rainwater, a low ridge of southern Appalachian farmland under a gray summer sky, showing nothing to distinguish it from 10,000 other road cuts across the Ridge and Valley province. Then you step down into the clay. The soil under your boots is not glacial till, and it is not local mountain runoff. It is a dense, black, anaerobic muck, 5 million years old, packed with the bones of ancient rhinos, alligators, tapirs, and a species of red panda found nowhere else on Earth. The remarkable thing about the gray fossil site is not merely that a warm, subtropical sinkhole ecosystem lay preserved under the pastures of eastern Tennessee. It is that hundreds of thousands of vehicles had driven directly over the top of it for nearly a century without a single geologist suspecting its existence. The road was built in the 1930s. The cut was widened in the year 2000. For decades, the highway carried daily traffic across a Pliocene time capsule that completely inverted what science believed about the prehistoric climate of eastern North America. How many more of these colossal anomalies sit buried directly beneath the most heavily traveled corridors of our everyday landscape, hidden only by a few meters of overburden? The source material for this investigation follows a systematic count across a defined geographic territory, running through 35 distinct phenomena, anomalies, and structural secrets. We are examining the hidden geography of East Tennessee, a region where the surface terrain of parallel ridges and quiet river valleys conceals one of the most complex, highly fractured, and hydrologically volatile landscapes on the North American continent. Before any modern survey crew laid a chain across this ground, the human geography was already deeply established. For thousands of years, indigenous peoples, including the ancestors of the Cherokee Nation, traveled, named, and understood the complex pathways of these mountain passes and subterranean drainage networks. What the early colonial land offices recorded as trackless wilderness was a fully inhabited territory with known trails along the valley floors and established uses for the mineral springs and rock shelters. The official record, the paper map sheet, the boundary survey, the geological bulletin, was not a discovery of new ground, but the late application of a foreign administrative grid onto an ancient landscape. Where early settlers saw simple limestone hills, the underlying geology held vast structural surprises. Consider item 34 on our survey. Deep within Monroe County, more than 90 meters beneath the surface forest, lies Craighead Caverns. What appears on the surface as an ordinary wooded hill holds the Lost Sea, a subterranean body of water spanning over 1.6 hectares of visible surface area. When a young boy named Ben Sands squeezed through a narrow crawlspace in 1905, he was not entering a simple cave pool. Modern sonar and cave divers have since shown that the visible lake is merely the top of a colossal, flooded cavern system extending hundreds of meters into the limestone matrix, with vast underwater chambers that remain completely unmapped to this day. Further north in Sevier County, at Elkmont within the Great Smoky Mountains, another overlooked phenomenon takes place every June. Item 33 reveals an extraordinary biological synchronization. Thousands of Photinus carolinus fireflies flashing their lanterns in absolute millisecond unison across the pitch-black forest floor. For generations, visitors assumed these were simple, random insects. It was only when entomologists examined the display with high-speed cameras that they realized the local population achieves a level of neurological coordination without central leadership that continues to puzzle mathematical modelers. And in Cumberland County, item 32 presents a hydrological anomaly of staggering scale. Grassy Cove is a giant karst depression, a collapsed limestone valley several kilometers long and wide, with no surface outlet whatsoever. Every drop of rain that falls into this vast agricultural bowl disappears into Mill Cave, traveling for kilometers through an invisible subterranean labyrinth beneath the mountain before re-emerging at the head of the Sequatchie River. The assumed simplicity of the landscape was entirely reasonable in its time. To the eye, the valley floor looks solid, the hills appear stable, and the rivers seem to follow predictable courses on the surface. But beneath that familiar crust lies a dynamic, hollowed, and tectonically fractured basement, one that science is still mapping, one cave system and one road cut at a time. We begin this second segment with item 31, located within the damp subterranean limestone passages of Monroe County. Here, deep inside Craighead Caverns, paleontologists from regional universities uncovered a set of fossilized footprints preserved directly in the mineralized mud. Thousands of years ago, during the Pleistocene epoch, massive prehistoric jaguars, Panthera onca augusta, a subspecies significantly larger than modern jaguars, navigated deep into these pitch-black cave systems without any artificial light source. The footprints dried and calcified over millennia, creating a pristine record of large apex predators moving through subterranean voids. The survival of these delicate tracks, along with fossilized bone fragments of extinct megafauna, provides crucial baseline evidence for how Pleistocene species utilized dark karst terrain during periods of intense climatic fluctuation. Moving north to Sullivan County, item 30 highlights an anomaly of survey history where human political boundaries clash with urban geography. The city of Bristol sits directly astride a historic geopolitical dividing line. State Street runs along the precise line laid down during early colonial surveys conducted with iron chains and magnetic compasses that failed to follow the intended parallel of latitude cleanly. As a result, the physical street divides the municipality into two distinct legal and administrative zones: Bristol, Tennessee on the south and Bristol, Virginia on the north. Rather than causing administrative collapse, local city planners embedded brass markers directly into the pavement of the thoroughfare, establishing a unified downtown infrastructure where a single step across the center line changes one's administrative and legal jurisdiction. Item 29 takes us into the high-altitude terrain of Sevier County, where Mount LeConte rises to an elevation exceeding 1,980 meters above sea level. This massive vertical relief forces moisture-laden air masses upward, creating an isolated climatic island that closely mirrors the environmental conditions of the Canadian subarctic. The summit experiences extreme precipitation, frequent freezing fog, and severe temperatures that generate a dense spruce fir forest dominated by red spruce and Fraser fir. Because no paved roads reach the upper crest, essential supplies for the high-altitude lodge must be transported several times each week by a dedicated pack train of llamas, traversing steep, rocky trails where conventional wheeled vehicles cannot operate. In Bledsoe County, item 28 brings us to the remarkably linear landscape of the Sequatchie Valley. This continuous trough extends for more than 160 kilometers, maintaining a straight course easily discernible from orbital satellite imagery. Geologists with the Geological Survey of Canada and regional geological institutes note that this feature was formed by the erosion of a colossal anticline, an arched fold in sedimentary strata produced during the mountain-building collisions of the Allegheny orogeny. Over millions of years, surface runoff dissolved and eroded the softer limestone core of the arch, causing the top sandstone layers to collapse inward. This process created a classic inverted topography. What was once a towering mountain ridge transformed into a flat valley floor bounded by parallel sandstone escarpments. Item 27 examines a violent hydrological disruption within Blount County, known as the Sinks. At this location along the Little River, the full volume of mountain runoff plunges over a massive rock shelf into a deep whirlpool before entering subterranean bedrock channels. The physical geography of this pool was permanently altered during the late 19th century by human intervention. Logging crews attempting to clear a massive timber jam detonated heavy charges of dynamite against the rock bed. The explosion fractured the underlying limestone layer, opening deep subterranean voids and altering the river's flow dynamics forever. Today, a persistent underwater vortex forms continuously inside the shattered basin, posing severe hazards for search and rescue operations. In Cocke County, item 26 shifts the scope to evolutionary biology and habitat stability. The cool, moist slopes of the southern Appalachian Mountains support over 30 distinct species of salamanders within a single localized geographic area, making this region the global center of amphibian diversity. Millions of years of climatic stability, combined with unglaciated terrain and abundant mountain precipitation, allowed lungless salamanders of the family Plethodontidae to adapt to highly specific ecological niches along small microstreams and forest floor leaf litter. Item 25 takes us to Hamilton County, where the Tennessee River Gorge cuts directly through the Cumberland Plateau. Known as the Grand Canyon of Tennessee, this 42-kilometer canyon features sandstone cliffs rising more than 300 meters above the water. Rather than diverting around the resistant plateau, the ancient river maintained its established course as the land slowly uplifted around it, carving a continuous gorge over millions of years. Item 24 expands on this biological richness within Sevier County. The Great Smoky Mountains preserve over 130 native species of trees, a botanical tally greater than that of the entire European continent. During the last glacial maximum, when continental ice sheets covered vast expanses of North America, these deep southern valleys and high ridges served as a critical refuge, allowing northern plant lineages to survive alongside southern species. Finally, Item 23 highlights the Ridge and Valley Province stretching across Granger County. This landscape consists of an alternating sequence of long, parallel sandstone ridges and low limestone valleys running from northeast to southwest. Tectonic compression during continental collisions folded the sedimentary layers, and selective erosion over hundreds of millions of years carved out the softer shale and limestone while leaving the hard sandstone intact. This corrugated terrain created formidable physical barriers for early transport routes, shaping human movement across the region for centuries. But what happens when modern industrial extraction collides directly with such complex geological structures? Part 3 brings us directly to the technical instruments and analytical methods that changed how geologists interpreted these terrain anomalies. Consider Item 22 in Blount County, deep within Tuckaleechee Caverns. For decades, local residents knew of a large cave opening, but it was only through dye tracing studies and subterranean hydrological surveys conducted by speleologists that the true scale of the system emerged. Hydrologists injected non-toxic fluorescent tracer dyes into White Creek, high in the Great Smoky Mountains, and monitored emergence points across the regional drainage network. The tests prove that the stream travels continuously through pitch-black subterranean chambers, including the Big Room, a cavern vault large enough to contain a professional sports stadium, before emerging kilometers away as a major freshwater spring. In Sevier County, Item 21 highlights Kuwohi, formerly known as Klingman's Dome, rising to an elevation of 2,025 meters. Early land surveyors estimated mountain heights using simple barometric altimeters and triangulation with theodolites, often miscalculating elevations by hundreds of meters. Modern differential GPS surveys and digital elevation models derived from airborne laser scanning confirmed its exact stature as the highest peak in Tennessee. Meteorological monitoring stations installed near the summit revealed annual precipitation totals exceeding 2,150 millimeters, proving that this high-altitude ridge functions as a temperate rainforest biome, isolated in the southern atmosphere. Item 20 turns to Polk County and the Copper Basin, where historical aerial photograph interpretation and soil core sampling documented one of the most severe human-induced environmental transformations in North America. Beginning in the mid-19th century, open-air heap roasting of copper sulfide ores released massive plumes of sulfur dioxide gas. Historical soil profile analyses conducted by agricultural researchers showed that acid precipitation completely stripped the organic topsoil layer down to the bare, reddish clay, initiating deep gully erosion across thousands of hectares. Aerial surveys from the 1930s captured a barren, desert-like landscape in the middle of a temperate forest belt. Further north along the Clinch River in Anderson County, Item 19 details the hydrological transformation executed at Norris Dam. In the 1930s, engineers with the Tennessee Valley Authority utilized precise cadastral mapping, aerial photography, and diamond core drilling into the limestone bedrock to site the massive concrete structure. The resulting reservoir covered over 13,700 hectares and created more than 1,280 kilometers of shoreline. Geodetic surveys and flood control mapping records confirm that the flooding submerged entire 19th century farming settlements, permanently altering the regional hydrology and river geometry. Item 18 brings us to Claiborne County and the Middlesboro Basin, located directly adjacent to Cumberland Gap. For generations, topographers assumed this circular depression, 3 kilometers in diameter, was a simple volcanic or erosional sinkhole. It was only when geologists examined drill cores and thin sections under petrographic microscopes that they discovered shatter cones and planar deformation features in quartz grains, unmistakable microscopic signatures of hypervelocity impact shock. Seismic reflection profiling and regional geological mapping confirmed that a meteorite struck the area hundreds of millions of years ago, shattering the hard sandstone strata and accelerating local erosion, which ultimately carved out the strategic pass used by early migrants. In Anderson County, Item 17 shows how physical geography was mapped for national security during the mid-20th century. Military topographers analyzing topographic map sheets and aerial photographs recognized that the long, parallel sandstone ridges of the Ridge and Valley Province provided exceptional visual concealment and acoustic shielding. In 1942, federal authorities selected this site for the Manhattan Project, constructing massive uranium enrichment plants within isolated parallel valleys. The natural topography acted as a physical barrier, ensuring that an industrial accident in one valley would not destroy facilities in the next. Item 16 highlights Morgan County and the blue ghost firefly, Phausis reticulata. Entomologists, utilizing low-light photographic recording and precise habitat sampling, revealed that these wingless females require undisturbed hardwood leaf litter and mature canopy coverage. Unlike species that blink, these fireflies emit a continuous blue-green luminescence mere centimeters above the soil layer. Item 15 examines Roan Mountain along the Carter County border, where botanical transect sampling and soil horizon analysis mapped the largest natural Catawba rhododendron garden on Earth, spanning hundreds of hectares of high-altitude southern Appalachian bald. In McMinn County, Item 14 examines the East Tennessee seismic zone. Geophysicists using high-density networks of digital seismographs and cross-sectional seismic tomographic mapping revealed that hundreds of micro-earthquakes occur annually deep within the ancient crystalline basement rock, 5 to 20 kilometers below the sedimentary surface. Item 13 takes us to Bradley County, where acoustic Doppler current profilers and river gauge telemetry during major flood events recorded the Hiwassee River completely reversing its flow direction for several kilometers due to hydraulic pressure bottlenecks at its confluence with the Tennessee River. Finally, Item 12 in Campbell County features the Devil's Racetrack. Structural geologists using strike and dip compass measurements mapped near vertical slabs of Pennsylvanian sandstone tilted at 90 degrees by the Allegheny orogeny, exposed after softer surrounding shale eroded away over epochs of time. But how do these deep geological structures shape the human-built environment and economic history of the surrounding towns? In Knox County, Item 11 brings us to a material that transformed both regional urban architecture and national construction history. Tennessee pink marble. Geologically classified not as a true metamorphic marble, but as an extraordinarily dense, crystalline limestone of the Ordovician-Holston Formation, this rock formed approximately 480 million years ago in a shallow marine environment. Composed of fossilized bryozoans and marine shells, trace concentrations of iron oxide give the polished stone its distinctive, warm, pinkish-gray tone. Intensive quarrying operations in the late 19th and early 20th centuries extracted millions of tons of this rock, supplying major national monuments, including the National Gallery of Art in Washington, and giving Knoxville its historic moniker as the Marble City. Item 10 examines the artificial lacustrine geography of Jefferson County. In the early 1940s, the Tennessee Valley Authority constructed major dam projects that impounded the Holston and French Broad rivers, forming Cherokee Lake and Douglas Lake. These vast reservoirs flooded thousands of hectares of fertile agricultural bottomlands, permanently submerging 19th-century communities, roads, and ancient indigenous habitation sites beneath tens of meters of water. Today, these managed reservoirs regulate regional flow across the Upper Tennessee River watershed, though seasonal drawdowns regularly reveal drowned roadbeds and foundations along the mudflats. In Meigs County, Item 9 highlights a vital ecological crossroads at the confluence of the Hiwassee and Tennessee rivers. The Hiwassee Wildlife Refuge encompasses roughly 2,400 hectares of shallow water channels, mudflats, and flooded fields. This specific hydrological setting makes it the primary wintering sanctuary for over 20,000 sandhill cranes annually along their eastern flyway, offering crucial protection from terrestrial predators and rich aquatic foraging opportunities. Item 8 features the rugged sandstone escarpments of Rhea County along Walden Ridge. Within the Laurel Snow State Natural Area, Richland Creek and Laurel Creek have carved deep, vertical ravines into Pennsylvanian sandstone layers. These narrow gorges generate sheltered microclimates that shield rare, temperature-sensitive plant communities, while Laurel Falls plunges over 24 meters into deep plunge pools, exposing thick deltaic sedimentary sequences. In Greene County, Item 7 examines an extraordinary structural feature known to earth scientists as a geological fenster, or window. During ancient continental collisions, massive thrust faults shoved older rock sheets completely over younger sedimentary layers. Over millions of years, river erosion carved through the upper thrust sheet, creating an opening that exposes the younger rocks beneath. This natural window allows geologists to analyze deeply buried structural layers directly at the surface without exploratory drilling. Item 6 shifts to Hawkins County, where a section of the Clinch River near Kyle's Ford harbors one of North America's most significant freshwater mussel sanctuaries. Biologists have recorded over 40 distinct species of native mollusks within a single reach of gravel riffles, including endangered species like the pale lilliput and shiny pigtoe. These organisms continuously filter massive volumes of water, acting as biological indicators for the health of the upper river basin. In Unicoi County, Item 5 highlights the Nolichucky River Gorge, a canyon slicing 450 meters deep through the Unaka Mountains. The Nolichucky is an antecedent stream. It predated the uplifting of the mountains. As tectonic forces slowly elevated the range millions of years ago, the river maintained its path, cutting into solid granite bedrock to form a wild, technical whitewater channel completely undammed and isolated from urban development. Item 4 takes us to Marion County and Nickajack Cave. Sliced into limestone near the Tennessee River, this colossal cave portal, over 42 meters wide, was partially submerged in 1967 following the construction of Nickajack Dam. Despite the higher water level, the internal microclimate remains stable, serving as an essential maternity roost for over 100,000 endangered gray bats every summer. Item 3 details the complex karst drainage of Newman Ridge in Hancock County. Composed of fractured Mississippian limestone, the ridge captures surface runoff through thousands of sinkholes and losing streams, directing water through an unmapped subterranean network that reemerges in massive freshwater springs feeding the Clinch River. But what lies in the final two places on our survey, where human engineering and natural rock shelters reach their absolute limit? In Fentress County, Item 2 brings us to the massive sandstone rock houses nestled along the western margin of the Cumberland Plateau, within Pickett State Forest and Pogue Creek Canyon. These colossal, shallow natural shelters were carved over millions of years as freeze-thaw cycles, wind, and water selectively eroded the soft underlying shale strata beneath resistant sandstone ledges. Spanning tens of meters across, these overhanging arches provided crucial shelter for indigenous populations thousands of years ago. Today, the deep, isolated topography of these sandstone gorges blocks artificial light pollution from nearby settlements, earning the area designation as an International Dark Sky Park, where astronomical research and archaeological preservation meet. Finally, Item 1 brings us to Loudoun County, where the Little Tennessee River meets the main channel of the Tennessee River. This massive hydrological junction has dictated human settlement and transport geography for millennia. Geologically, sweeping river bends cut through soft limestone strata to create fertile, defensible peninsulas used by early indigenous nations and European garrisons alike. The completion of Fort Loudoun Dam in 1943 permanently transformed this river geometry, creating a deep navigation reservoir that marks the head of continuous commercial barge transport, extending all the way down to the Gulf waterways. This engineered confluence links localized structural geology directly with continental shipping networks. What kept these 35 phenomena unnoticed for so long was not a lack of interest or skill among early topographers, but a fundamental habit of assumption. Land surveyors and geologists mapped what was visible on the surface and assumed the underlying bedrock followed the same predictable, solid logic. Even today, vast sections of these subterranean networks remain completely unmapped. Speleologists, hydrologists, and geophysicists continue to drill cores, trace dye paths, and deploy sensor arrays across these counties. But every new survey line reveals further voids in the limestone matrix that resist easy classification. The map printed on paper or displayed on a screen appears finished, neat, and complete. The ground beneath it is not. Which feature across your own region or province has always struck you as geologically out of place? Tell us in the comments below, and consider subscribing to join us for our next geographical investigation.